Business Statistics, Measures of Variability, presented by Meily Juliani SAMM. Learning Objectives. The first, student will be able to describe various measures of variability of ungrouped data. The second, student will apply various measures of variability including the range, inter-quarter range, mean absolute deviation, variance, standard deviation, z-scores, and a coefficient of variation to a set of ungrouped data. First, we will learn about what is measure of variability. In the previous meeting, we have learned about the measure of central tendency, which can be used to yield information about the center or middle part of a data set. However, business researcher can use another group of analytic tools, such as measure of variability, to describe the spread or the dispersion of a set of data. There are 7 measures of variability of ungrouped data, which is range, inter-quarter range, mean absolute deviation, variance, standard deviation, z-scores, and coefficient of variation. The first, we will learn about range. The range is the difference between the largest value of a data set and the smallest value of a set. Advantage of range is it's easy to compute, and the disadvantage of the range is it is affected by extreme values. Since the range is based solely on the 2 most extreme values within the data set, if one of these is either exceptionally high or low, sometimes referred to as outlier, it will result in a range that is not typical of the variability within the data set. The formula of range is highest minus lowest. For example, a large bakery regularly orders cartons of Meily blueberries. The average weight of the cartons is supposed to be 22 ounces. Random samples of cartons from 2 suppliers were weighed. These are the weights of cartons from supplier 1 and supplier 2. Compute the range of carton weights from each supplier. So we get back to the formula, which is range equal largest value minus smallest value. So the range of supplier 1 is 27 minus 17 equals 10 ounces. And from supplier 2 is 28 minus 17 equals 11 ounces. Inter-quarter range. The inter-quarter range is the range of values between the first and third quartile. The inter-quarter range is especially useful in situations where data users are more interested in values toward the middle and less interested in extremes. For example, in describing a real estate housing market, realtors might use the inter-quarter range as a measure of housing prices when describing the middle half of the market for buyers who are interested in houses in the mid-range. The formula of inter-quarter range is quarter third minus quarter first. Example. The following data indicate the top 15 trading partners of the United States in export in a recent year according to the U.S. Census Bureau. What is the inter-quarter range for this data? The process begins by computing the first and the third quartiles as follows, using the formula we have learned from the last meeting. Solving for Q1 equals P25 when n equals 15. In here, it means that there are 15 data. I equals 25 per 100 times 15 equals 3.75. Because I is not a whole number, P25 is found as the fourth term from the bottom. Q1 equals P25 is 23. So the quartile first is 23. Solving for Q3 equals P75. I equals 75 per 100 times 15 equals 3.75. Because I is not a whole number, P75 is found as the 12th term from the bottom. Q3 equals P75 equals 58.1. So the third quarter is 58.1. The interquartile range is Q3 minus Q1 equals 58.1 minus 23 equals 35.1 in billions. Mean absolute deviation. The mean absolute deviation, acronym MAD, is the average of the absolute values of the deviation around the mean for a set of numbers. In other words, the MAD tells you how much the data set deviates of course or from the average. The formula of MAD is sigma x minus sigma mean per n, where MAD is mean absolute deviation, sigma is total, x is data, mean, and absolute. Example: suppose a small company started a production line to build computers. During the first 5 weeks of production, the output is 5, 9, 16, 17, and 18 computers respectively. Compute a mean absolute deviation. As you can see, there are 3 columns here, and X represents the data. There are 5 data here, and the total of the data is 65. In the second column, there are X minus mean, which means that we have to find the average of the data first. So the average of the data is sigma x per n equals 65 per 5 equals 13. And the next step that we have to calculate the data minus the average, which is 5 minus 13 equals minus 8, and so on. In the third column, we have seen an absolute sign, which turns the numbers into positive. So you can see minus 8 turns plus 8. And the total of the data is 24. So the MAD is 24 per 5 equals 4.8. Variance. The variance is the average of the squared deviation about the arithmetic mean for a set of numbers. The population variance is denoted by sigma square. This is the formula of variance, where sigma square is population variance, x is data, mean, n is total data. Standard deviation. The standard deviation is the square root of the variance. The population standard deviation is denoted by lowercase sigma. This is the formula of standard deviation. As you can see, standard deviation equals square root of the variance. Here is an example taken from the previous problem. In the third column, as you can see, the formula is x minus mean squared, and the total is 130. So the variance is 130 per 5 equals 26. And the standard deviation equals square root of 130 per 5 equals 5.1. Z-score. A z-score represents the number of standard deviation a value is above or below the mean of a set of numbers when the data are normally distributed. Using z-score allows translation of a value's raw distance from the mean into units of standard deviation. These are the formula of z-score, where z is z-scores, x data, mean, and standard deviation. Because a z-score is the number of standard deviation an individual data value is from the mean, the empirical rule can be restated in terms of z-scores. These are the three terms. The larger the absolute value of the z-score, the farther the data value is from the mean. Example: suppose the mean Math S80 score is 490 with a standard deviation of 100. Compute the z-score for a test score of 620. So the answer is z equals 620 minus 490 per 100 equals 130 per 100 equals 1.3. A score of 620 is 1.3 standard deviation above the mean and will not be considered an outlier. Coefficient of variation. The coefficient of variation is a statistic that is the ratio of the standard deviation to the mean expressed in percentage and is denoted by CV. The coefficient of variation can be useful in comparing standard deviation that have been computed from data with different means. These are the formula of coefficient of variation. Example: suppose 5 weeks of average prices for stock A are 57, 68, 64, 71, and 62, and the average prices for a second stock B over the same 5 weeks are 12, 17, 8, 15, and 13. Compute the coefficient of variation of both stock A and B. The answer is, to compute a coefficient of variation for these prices, first, we have to determine the mean and standard deviation, which is mean is 64.40 and standard deviation 4.84. The coefficient of variation stock A is CVA equals 4.84 per 64.40 times 100 equals 0.075 equals 7.5%. So, the standard deviation is 7.5% of the mean. The second one, the mean for stock B is 13 with a standard deviation of 3.03. The coefficient of variation can be computed for stock B as CVB equals 3.03 per 13 times 100 equals 0.233 equals 23.3%. So, the standard deviation for stock B is 23.3% of the mean. Here is the analysis from the example. With the standard deviation as the measure of risk, stock A is more risky over this period of time because it has a larger standard deviation. However, the average price of stock A is almost 5 times as much as that stock B. Relative to the amount invested in stock A, the standard deviation of $4.84 may not represent as much risk as the standard deviation of 3.03 for stock B, which has an average price of only $13. The coefficient of variation reveals the risk of a stock in terms of the size of standard deviation relative to the size of the mean in percentage. Stock B has a coefficient of variation that is nearly 3 times as much as the coefficient of variation for stock A. Using coefficient of variation as a measure of risk indicates that stock B is riskier. This is the end of this lesson. Thank you for your attention.